So guys, let me introduce myself. This is Manoj here. I'm having around 15 years of industry experience. And this is kind of an introductory class will be there about Kubernetes. But when you will join our course, you will get to know each and every concept in detail. Okay. So guys, the first is need for the Kubernetes. Before need of the Kubernetes, I will spend some time to make you people understand about the Docker. Then exactly what can be covered, what cannot be covered, how does it work, architecture of the Kubernetes, and then I will show you creating a Kubernetes cluster. Okay, so let's get started, guys. So let me first make you understand what is the Docker, concept of the Docker. So why Docker came in picture? Okay, so guys, let's say if I'm working in an environment, okay, I'm working in an environment, okay, and in the environments I have multiple categories are there, like dev environment, the QA environment, okay, the dev environment, the QA environment, the uh, SIT environment, the pre-prod environment, and the prod environment. So when I'm developing a code in my environment, I have an installation layer is there, okay, and I have a dev configuration layer is there. Okay, for example, if I have a Tomcat server is being installed, so I have a Tomcat installation is there. If I want to change the port numbers of the Tomcat, so I have a configuration layer is also there, okay, for me, which is same across all the environments. Okay, now guys, whenever I deploy the new component, so this is an observation that my deployable component works fine in the lower environment. Okay, let's say I'm deploying any deployable component that works fine in the lower environment. Okay, but when it moves to the higher environment, it doesn't work. For example, if I'll deploy my code into the dev and the QA environment, it looks they work fine, but the moment they reaches to the higher environments, okay, you will see them that they are not working as expected. Can someone tell me why they doesn't work when it moves the code into the higher environment? Can someone tell me why it doesn't work when the code moves to the higher environment? Why it doesn't work when it moves to the higher environment? Yeah, because of might be when the environments were formed, okay, the configuration and installation layers were same, like this installation layer and the configuration layer versions might be same. Later point of time, it would have been changed. For example, when probably the environment was set up, we were installed Java 6, but a later point of time, okay, for other environments, okay, because of any troubleshooting reason, because of any of the housekeeping activities, their versions has been degraded or upgraded. So because of multiple reasons, configurations would have been changed, and that is the reason our code doesn't work in the higher environment, right? So what is the solution to that problem is, solution to the problem is, if I will package all the three things together, like the installation layer, configuration layer, and the deployment layer, and then I must be deploying it as a package, then my environmental level dependencies will be ruled out, and I can ensure that my deployment works in all the environments seamlessly. For example, if I'll take the same example, and I will take so I have QA is there, SIT is there, pre-prod is there, prod is there. Okay, so what I must be doing is now I must be packaging all the dependencies in a package solution. So what I must be doing is I must be packaging all the dependencies, my installation layer, my configuration layer, my deployment layer. So what I must be doing is I must be packaging this, and I'll be deploying this entire package together instead of deploying only the deployable components. If I'll be deploying entire package together, okay, when I'll be deploying this part together, this part together, this part together, this part together, then I can get rid out of my problems of having different configurations in different environments, right? Okay, so guys, agree with this approach? Can I solve my problem of having different configurations so that my code should work seamlessly from lower environment to the higher environment? Now this package, we are calling it as a container. Let me write it somewhere. So this is nothing but a container. Okay, with the help of container, you can package your dependencies in a single package. So guys, again the question is, if container is doing good, then how container is different from virtual machines? Because nowadays there is a discussion is going on how virtual machines are different from containers. Okay, so what did SIT means? System integration testing environment. So guys, system integration testing is the SIT environment. Now, so I'll tell you what is the difference between virtual machines and the containers. So this is just a recap, guys. So I'll not go in depth into the virtual machines and this difference, but I'll tell you very high level what is the difference is there. So whenever you go for a virtual machines, okay, you will have underneath hardware is there. On top of that, you might have an operating system. You might have operating system, might have or might not have, because we have both kind of systems are available. On top of that, we will have a hypervisor is there. So hypervisor is what? Hypervisor is a software which will help you to create multiple virtual machines. So there is a hardware is there. On top of that, operating system is there. Okay, on top of that, operating system is optional or maybe mandatory. Both the things are there. It depends upon the which kind of hypervisor you are using. Few hypervisor doesn't need operating system underneath. Few hypervisor needs a operating system underneath. Okay, so let's say assume that I have operating system is there. On top of that, a hypervisor is there. On top of that, I have multiple virtual machines have been created. Let's say I have created uh, 3 virtual machines, v1, v2, v3. So this is the typical arrangement in a virtual machine world. Now when it compares to uh, containerization, so what we will be doing is, in containerization world also you will have a hardware is there. Okay, on top of that operating system is there. So here instead of hypervisor you will have a software is there which will help you to create container environment, that is Docker engine. Okay, on top of that, instead of virtual machines, you will be having different containers. Okay, on top of that, you will have a different containers are there, D1, D2, D3. So you will have multiple containers on top of that. We have same type of arrangement is there in between virtual machines and the containers. Then what is the difference between them? So around, let me take 2 GB of RAM is there, okay, which is required to start the operating system. On an average, I'm taking. V2 also OS is taking 2 GB of RAM. V3 also it's taking 2 GB of RAM. Now guys, in the V1, okay, if I have to run an application which will consume 0.5 GB of RAM, so my overhead is 2 GB of RAM, which is a operating system RAM. Again, for app equals to, let's say 1 GB of RAM is required if I'm running an application. Again here, if I'm running an application, let's say 1.5 GB of RAM is required. So you'll see all together OS dependency, I need 6 GB of RAM. Okay, an app I required almost 3 GB of RAM. Okay, so you can see that if I have to run an application which consumes 3 GB of RAM, for that I will have a dependency of a 6 GB of RAM. So a double overhead is there. Okay, let's say boot up time is 2 minutes are there. Now if I'll compare these figures with the containers, so you will see the drastic change would have come when it compares to containers to here. Okay, so you will be surprised to see that containers doesn't need any memory to start, or if it needs, it's in very minimal memory which can be ignored, which should not be counted, maybe 0.01 MB or 1 MB or 10 MB, very less memory. Okay, so in case of containers, your overhead of starting the virtual machine type, unlike like operating system, there won't be any overhead. So whatever memory is required to our application, okay, you must be required only that much of memory. So your OS level dependency is not there. Okay, and you can see instead of 6 GB as compared to virtual machine, in container world it's 0 GB is required. Okay, so our saving is huge. Instead of 6 GB versus 0 GB, and this memory can be used for starting more applications. Okay, now when it comes to the startup time, guys, so the startup time of the container is 1/20th of the second, single millisecond. Okay, the moment you will do iBlink, container should be started. A core container or plain vanilla container should be started. I'm not talking about the application startup time. I'm talking about the container startup time. It takes 1/20th of the second. The moment you will do iBlink, container would be getting started. Okay. Okay. Now, guys, I have a question for you. So it means that containers are replacing a virtual machine. Okay, in this case, if I install a different operating system, a VM as a compared to host operating system will have its own kernel. See, kernel will be of only host operating system. Guest operating system, which is lying in the container, will not have its own container. It will be sharing the container, which is of host operating system. Okay, so my question is, does it mean that containers are replacing the virtual machine? Does it mean containers are good to replace the virtual machine? Okay, so guys, gradually this is the plan, in the industry. Okay, industry wants to replace virtual machines with the containers, but to start a container underneath the operating system is required. So virtual machine cannot be completely ruled out in the market. Okay, apart from that, um, monolithic application, traditional application, legacy application, which carries the huge code base, they are not meant to be converted into the containers. Okay, but nowadays the companies are moving into the microservices based architecture. So more transformation in the microservices based architecture will leads to a container based implementation. Okay, now guys, good. One container is there, I can manage. Now suppose guys, okay, suppose guys, microservices world is there. So I'll tell you what is the background of the microservices world. Okay, earlier there was a web service is there. Okay, earlier there was a web service is there. Let's say web service 1, web service 2, and web service 3. Okay, let's say 3 web services were there in your project. Okay, now 3 web services were there in your project. Okay, which required 3 virtual machines. Okay, machine 1, machine 2, machine 3. Which requires machine 1, machine 2, and machine 3. Now guys, when we were in the SOA architecture, service oriented architecture, we were deploying our code into 3 virtual machines because we were having 3 web services. Now in the new microservices world, we have divided each web service into multiple microservices. Okay, multiple microservices. Let's say if I divided each web service into 5 microservices. M1, okay, if I will divide them in multiple microservices, okay, so let's say if I will divide such combinations for web services 2 also, web services 3 also. So now for 3 web services, I was using 3 virtual machines, right? So do you think for 15 microservices, I should use 15 virtual machines? 3 web service for 3, see, we are replacing web services with the microservices. So for microservices, do we need 15 virtual machines? No. Okay, then what is the solution, guys? Okay, they can run as a container. Okay, so let me containerize them. Okay, let me started them as a container. Now guys, if I have 15 microservices are there and for them we have 15 containers are there, then what would be the challenges are there to manage 15 microservices? What would be the challenges are there for 15 containers? Networking. Okay, right? Security, right? Security is also one of the aspect, right? So do you think guys you can manage all these things manually? Let's say if I am a developer or you are a developer, will I able to develop a script which will manage all these things, okay, by managing these many containers? Do you think it's possible? So what is the solution? Solution is only guys one, okay, that we should have a orchestration engine will be with us. A container orchestration or container orchestrator will be with us. Okay, So container orchestrator, okay, container orchestrator will be with us. Okay, and that is the reason, guys, people started thinking about a solution which can do all these things for you. So guys, which are the tools are there for container orchestration? Okay, so guys, to my knowledge, the first tool which was launched into the market was Apache Mesos, okay, which is nowadays kind of a dying tool. I don't see any implementation of Mesos, okay. And then another tool came into the market, which was Docker Swarm, okay. And then another tool came in market from, okay, that is Kubernetes. Okay, so Docker Hub is not a tool for container orchestration. Okay, inside Kubernetes now, inside Kubernetes, guys, a lot of flavors are there. Okay, so a lot of flavors are there. Can someone tell me what are the flavors are there inside Kubernetes now from different vendors? We'll quickly write down that flavor. Inside Kubernetes, kubeadm is one of the flavor. Okay, and AWS is saying EKS I'm giving, AKS uh, Azure is giving, Google is giving GKS for us. OpenShift is also one of the platform which is coming in the market. Apart from that, guys, any other flavor? Minikube is one of the option. Okay, so guys, if you want to spin up Kubernetes environment, there is a component is they'll call Cube Spray, that is also very famous in the market. Okay, apart from that, nowadays Helm chart has also come, Rancher has also come, so a lot of flavors have come, guys, of Kubernetes. Okay, so guys, I'm not telling which can be used for real time. Okay, I'm telling which are the flavors are there of Kubernetes. Okay, so these are the flavors are there of Kubernetes, and Kubernetes is the future, guys. Okay, so kubeadm will be used for, it can be used for on premises, it can be used for cloud. EKS is for Azure, sorry, AWS. AKS is for Azure. GKS, sorry, GKE, Google Kubernetes environment. GK is for Google. OpenShift is from Red Hat. Minikube, which was from single node cluster. Cube Spray from Ansible. If you want to have readily available playbooks. Helm charts is something, a new package has come of Kubernetes. Rancher is something which is helping us on the dashboarding part. So a lot of components are getting incorporated. Now let's open the Edureka slides. Okay, okay. They're faster, reliable, efficient, lightweight, and scalable. Okay, but what are the limitations are there? They are not easily scalable. When the number of containers will be growing, scalability is little tough. Okay, so problems with scaling up the containers are containers could not communicate to each other. Containers had to be deployed appropriately. Okay, let's say you have 50 containers are there. Which container will be a front-end container? Which container will be a back-end container? It will be a problem. They have to be managed carefully. Auto scaling is not possible. Distributing traffic was still a challenge. Okay, so these are the challenges are there, guys, which I talked also about. Okay, but there are some more organized challenges are there. We need a container management tool. Okay, so as I told, there are multiple tools are there. Its journey has started from Apache Mesos, then Swarm, then Kubernetes. Okay, Kubernetes was famous because Kubernetes is a giant, and it is from the Google, and later donated to CNCF. Yeah, so these are the features are there of Kubernetes. So I'll tell you with whatever we have learned. So self-healing. So if container dies, another container will be spin up. For example, if you set a replica of 4, so your orchestration engine will make sure that your replica will always be 4. Okay, so if a container dies because of any reason, let's say you have 5 virtual machines are there, in which virtual machines you are running five containers, because of any reason one virtual machine goes down. then other virtual machines will take the load. Self-healing techniques are there. Okay, second, horizontal scaling. Okay, let's say if you set the threshold that if my threshold of the application goes beyond 70% of CPU utilization, you should spin up one more container. So that is also there, that we call it as a HPA, horizontal pod scaling. Okay, secret and configuration management. So guys, secret and configuration management, as in whatever password you want to encrypt, okay, that will be very much encrypted. Okay, and if you want to plan some security like role-based accesses, that also can be done easily with the Kubernetes. Okay, service discovery and load balancing. Let's say if you have 30, 40, 300, 400 containers are there, how the load will be distributed. And service discovery, for example, okay, in your company you have two departments are there, HR department and the technical department. So your one set of containers will be serving HR department, one set of containers will be serving your other department. So when you will access a URL, for example, edureka.com/trainers/students, so how this service discovery will be happening, that is also very well possible with the Kubernetes. Storage orchestration. So whenever you store the containers and their logs, there is a ways there by which you can easily store, okay, their logs. So storage is also very much optimal there. That's why you're talking about the storage orchestration. Batch execution, if you want to run huge number of data with the help of containers, that is also possible. Automatic rollbacks and rollouts. Okay, if let's say while doing the deployments in the production, you will get to know that few of the containers are not responding, then easily they can be rolled back. Okay, that mechanism is there. So for containerization app, um, Kubernetes to best compare, Kubernetes cannot do containerization for you. I'll show you when we install it. Okay, Kubernetes is actually robust and reliable, a container orchestration platform, best solution for scaling up containers, backed by huge community that is there. So guys, there is some important Slack groups are there. You can join the Slack groups also. Okay, Kubernetes versus Docker, Kubernetes versus Docker Swarm. So I think this is clear. For to manage multiple containers, you have orchestration engine there, which could be a Docker, Kubernetes, or Docker Swarm. But yeah, there is a difference is there between Docker Swarm and Kubernetes, which people has to know. Okay, so guys, this is a difference is there between Kubernetes and Docker Swarm. Kubernetes is complicated to install and initially to understand. Swarm is just one liner is there. It will be helping you to install the Swarm. Okay, Docker Swarm GUI is not available. Third-party plugins are available which you have to use. But for Kubernetes, GUI is available. Okay. Scaling up is slow compared to Swarm, but guarantees strong cluster state. So like whenever you change the number of replicas, Swarm will be very much faster. Containers has little complex procedure is there, okay, inside containers, sorry, inside Kubernetes framework, but it guarantees that your container will not be crashed easily. Load balancing requires manual service configuration, provide built-in load balancing technique. Okay, so why this manual service configurations are there in load balancing in Kubernetes? Because in Kubernetes, four type of services are there. Okay, so which service you want to configure, it's upon you. But where in Swarm, that four type of configurations are not required. Only one type of configurations are there. Updates and rollbacks, process drilling to maintain services while updating. Progressing updates, service health check throughout the update. So I think here Docker Swarm is little better, but again for the long term, for the huge volume, updates and rollbacks can be easily managed because Kubernetes supports A to B deployment, blue-green deployment, canary analysis, multiple things. Data volumes only shared with containers in the same prod can be shared with any kind of container. Okay, so data volumes, what happens is, okay, let's say if you want to share with something, if you want to share a log of a container, so here in Docker Swarm, you have to share it with some other container. But in case of Kubernetes, we have pod concept is there. So there is a init container is there. You can share your logs over there so that you can stream them to be accessed by a third-party tool like Grafana, Kibana, or anything. Inbuilt logging is there in the containers, but in Docker Swarm, logging is not that great. You have to manage logging by your own. Okay, so let's move on to the next slide. So guys, this is the typical architecture of Kubernetes. Okay, wherein we will have some one master component is there. Rest is our slave components are there. Okay, in this master and slave, we have a API server is there. Okay, which is nothing but how you communicate to the command line. Okay, and then we have a controller manager is there, scheduler is there, etcd is there. Okay, these components are on master side. Okay, and these components are on the slave side. Okay, so to make it very easy, I have created one slide, guys. Okay, you can see a developer is there when he wants to communicate with the master and the slave. So we have a master component is there, we have a slave component is there. Inside master, we have a API server is there. So nothing, guys. If you want to use your Kubernetes cluster programmatically, okay, so you have to have some APIs console will be there, which can be called using commands. So that is your API server. Okay, so component of the master that exposes the Kubernetes API front end for Kubernetes control plane. So nothing, if you want to use programmatically Kubernetes, you should have a REST APIs exposed. Second is controller manager, then scheduler is there. So component on the master that watches newly created pods that have no node assigned and select a node for them to run. So for example, when you are given a replica of 5, okay, so it will adjust these components into the different virtual machine all on the nodes. So next is kubelet is there, guys. So kubelet is sitting onto the master and slave. So what is kubelet job is? Kubelet is nothing but this is a agent on the slave or master machine, which ensures that your pods are nothing but containers are running on within the machine. Okay, kubeproxy, it enables the Kubernetes service abstraction by maintaining network rules on the host and performing the connection forwarding. So it's nothing, guys, for networking purpose. We have kubeproxies there. Okay, and we have something is there like how one node will communicate to another node. For that, we have something called CNIs are there. Okay, container network interfaces are there. So multiple type of container network interfaces are there. So guys, there are two networking concepts are there. One is a networking concepts within your a node wherein containers are running or pods are running. That is through kubeproxy. But when one node will communicate to another node, that is through this particular CNI container network interfaces. Could be many things, Calico, Flannel. Okay, on top of that, pods are running. So what is a pod, guys? So pod is nothing, right? So whatever container we are learning, so in Kubernetes world, we are calling that containers as a pod. Then what is the difference between container and a pod? A pod can have more than one container. Okay, and why we need more than one container? Sometime you need a sidecar container which will help you to download a dependency. For example, to start a container, you need some dependencies to be downloaded. So you will have one additional container is also given in a pod. So pod can have one container or a multiple containers. So that is the beauty of the Kubernetes, that it allows more than one container in a pod. So logically, when you compare, there is no difference between a container and a pod. Only pod can have more than one container. Okay, what is a etcd? So etcd is nothing, guys. This is a brain of your entire cluster, wherein your container or cluster values are stored in the form of key value pair. Okay, it is stored in the key value pair. So for example, if you want to plan disaster recovery of your Kubernetes cluster, you can have more than one etcds. Okay, people who have worked on big data Hadoop, they must be knowing that they also store their cluster information in the form of etcd. And when they plan for multi-node cluster, they plan for actually multiple etcd databases. So etcd is nothing but a kind of NoSQL database is there, wherein key values are being stored. Okay, so this is the guys high level architecture is there. On the slaves we have kubelet is there, kubeproxy is there, CNIs are there. Okay, on the master side you have etcd is there, scheduler is there, control managers are there. Okay, so now let me open a document. I have a document with me which usually we give when we teaches people about the Kubernetes cluster. Okay, first what we have to do is, guys, we have to see whether OpenSSH is being installed or not. Okay, so what do you think, guys? OpenSSH should have been installed. Is it installed or we have to install it? I think it should be installed automatically. So let's install. So guys, what I'm doing is I have already created two machines. Okay, one is a master, one is a slave. So what I will show is I will set up the KubeADM and I will show you that one slave has joined the cluster. Okay, so on master and slave, OpenSSH has been installed. Now let me update the packages on both the places. So guys, we should have a container engine also available. Okay, so let me install the Docker. Okay, so let this Docker be installed on both the machines. Let me check Docker version. Yeah, this is installed on master. Let me check on the slave. Okay, installed. Now next is, guys, we have to install KubeADM, kubelet, and kubectl. Okay, all the three components on both the places. For that, we have to first install the curl command, which doesn't come by default on both the machines. So let me pick up from the document command for curl. Curl command is getting installed. Afterwards, guys, we have to import some certificate in our operating system repository. Okay, done. Okay, afterwards, I have to add these certificates in my package. Okay, and then now I have to take some updates. Okay, now guys, after the updates, I will install KubeADM, kubelet, and kubectl. These three components are there which are required everywhere in the system, both the systems or entire cluster. Okay, so guys, I'm doing nothing. It's not logic or anything I'm applying. I'm just following the document. First, I installed the Docker to both the machines. Then I imported the certificates which has to be added in the repository of the operating system so that I can install these three packages: kubelet, kubeadm, and kubectl. Okay, now there are some environmental variables are there that has to be added in both the machines. 1 minute, guys. I think here it is not installed. My bad. 1 minute. Let me add this line in both the machines. Okay, so I have added this configuration both the machines. Okay, now guys, what we have to do is we have to initiate the kubeadm from master machine so that we can designate the master machine to be as a master. So what we have to do is we have to advertise our master for them kubeadm to be started. So what I have to do is I have to pass the IP address of the master. Okay, so I know the IP address of the master. I have saved it someplace. So since guys I am working on AWS, I am sharing here private IP address of my master. Okay, that is being shared. So guys, I did nothing. So first we installed the Docker, then we installed the kubeadm, then I added a configuration line. Now I am designating my master to become a master. Okay, nothing else. Okay, so guys, this is the command is there which I have to save it, because this command will be used to add any particular machine as a part of this cluster. So what I'll be doing is now, okay, there is one more command is there. To start using cluster, you need to run the following as a regular user. So I am with root user at the moment. Okay, so what I'll be doing is I'll be going to Ubuntu user. Okay, and I'll be running these three commands. Now my almost cluster is ready. Okay, but what I'll be doing is I will see whether my all the pods are running on master or not. So you will see that when I'm giving kubectl get pods. So kubectl is nothing but this is a command line tool is there to get all the pods. Okay, within the namespaces. Namespace is nothing but virtual cluster or the clusters within the Kubernetes cluster. So you can see two pods are running in the pending state. Why are they running in the pending state? Because that needs a CNI, Kubernetes, sorry, container network interfaces. So I have to install a container network interfaces. And if I'll do kubectl get nodes, you will see at the moment in my cluster, I have only one node is there. Okay, so two things I have to do guys. I have to fix this problem so that my all pods should be running, and I should add another slave as a part of my cluster. So what I'll do is I will search in the Google, install Kubernetes on Ubuntu. Okay, so somewhere I'll get this thing. Yeah, so this is the CNI is there which I have to use. So let me apply this CNI. So guys, CNI is nothing but this is a networking plugin is there which we have to install. Now you can see if I will run the command namespaces, now you can see pods are changing. Okay, some pending pods are coming in running state, running pods are coming in pending state. So we'll wait for some more time. Yeah, so some pods are still in pending state. Yeah, all are running, not all are running. Yeah, you can see now all the pods are running. So my cluster is ready guys, but in my cluster only master components are there. If I'll do kubectl get nodes, then you will see only master is there as a part of my cluster. So I saved this command. so that I can add any other node as a part of my cluster. So let me run this command in the slave machine. Okay, and you will see that this guy also will be joining my cluster. So this node has joined the cluster. Now if I'll do kubectl get nodes, you will see I have one more guy who's joined my cluster. Okay, so now I have two clusters are there. Okay, so guys, I wanted to show you quickly a hands-on part. That's why I was little fast. So I'll tell you what I did. So don't be confused when you will join our course. We'll explain each and every concept in detail. So what I've done is I pick up two virtual machines. Okay, in both the machines I installed Docker as a component. Okay, which is a required mandatory component. And I wanted to install kubeadm, kubectl, and kubelet, three components in both the machines. So what I did is first I imported the certificates, which will allow me to install these three packages. So I installed all the three packages in both the machines. Now, if you remember in the architecture, I told to communicate one machine to another machine, I need a network plugin. I call this network plugin as a container network interfaces CNI. So the famous CNI which we'll be using is Calico. So from the internet, I found a command which will help me to install the CNI, that is a Calico. So I installed the Calico CNI, which will help me to complete my cluster installation. Then my master I designated as a Kubernetes master, kubeadm master. Now my cluster is ready, but in my cluster only I had only one master machine. So I wanted to add slave machines into it. So whatever the command is there which will help me to add another machine to my cluster, I ran that command from the machine which I wanted to add as a part of cluster, and then the another machine joined my cluster. Okay, in my cluster now I have one master is there and one slave is there. Let's say if I want to add one more machine, so I have to do the same thing. I have to install all these components over there, and if I run this command kubeadm, okay, advertisement command to that particular machine, that also should be a part of my cluster. That's it. Okay, so guys, that's all from my side. Hope you guys enjoyed the session. Okay, and I would say, join our advanced course, then you'll get to know each and everything. Okay, and thanks for your time, guys, and hope you like the session. And I always say world is small, we'll meet again, and bye for now, guys. And since lockdown is going on, please don't go out from your house. Okay, do your all activities at home only, and be safe, be happy, guys. Bye for now.